Hi, the question we'll be answering says solve. Illustrate your final solution on a number line. And this is the inequality that we'll be solving. So first, I just want to address that solving an inequality means that we're going to find the values that, in this case, when put in as x, are going to make this statement true. So this expression is going to be greater than 0. So that said, I also want to point out that this is a rational inequality. And that's because this over here is a rational expression. And we know that because this is a polynomial over a polynomial. So before we start solving it, we're going to make sure that it's in general form. And what that means is that the rational expression is on the left of the inequality and the zeros on the right. So you can see that for this is true, left and right. So I'll check that off. Then secondly, we want to make sure that both the numerator and denominator are factored. And we can see that they are 3 factors right here. And now I want to say that solving rational inequalities is similar to solving polynomial inequalities. However, there's one key element in doing them, and that is finding the critical values. And what the critical values are, which I'm going to write down, is the numbers, the values you put in as x, which make the rational expression 0 or undefined. So those are going to be the zeros of the numerator, because when it's 0 divided by any number, that's going to equal 0. And they're going to be the zeros of the denominator, because whenever you divide a number by 0, you're going to get an undefined value. And what I also want to mention is that zeros of denominator are immediately disregarded as a possible solution because they make the rational expression undefined. So not a solution. Okay, so now we're just going to begin by finding the zeros of the numerator. And since it's already factored, that's quite easy. We're just going to take the numerator, and we're going to set factor to equal 0, solve for x. So we have x plus 3, we'll set it to equal 0, and that means that x equals -3. So this is the 0 of the numerator. So now we're going to find the zeros of the denominator, which are the restrictions or the undefined points. And we have the 2 factors, so there's going to be 2 zeros here. The first one is x minus 2, and we're going to do the same thing, set factor to equal 0 and solve for x. So x minus 2 equals 0 means that x equals 2. And now x plus 4, and we'll let it equal 0. So we get x equals -4. And those are the zeros of the denominator. Now we have all of the critical values for this inequality. So critical values are -3, 2, and -4. So what we're going to do with these critical values is they're going to give us intervals on a number line, and we're just going to test each of the intervals to find which ones are a solution for the inequality. So now we're going to take the critical values and make them intervals on the number line. So the first one that we have is x is less than -4, and that's just going to be right here. Then next we have x is greater than -4 but less than -3, and that's going to be in between here and written like this. And then after that we have x is greater than -3 but less than 2, and it's going to be written like this. And it'll just be from -3 to +2 over here. And the last one we have is x is greater than 2. Now I'm just going to select arbitrary test values of x, one for each of the 4 intervals, and evaluate it back into the original rational expression. And we're going to see if the number it equals is greater than 0 or less than 0 to determine if it's a solution for this inequality or not. So I will use a table to do this, but first we're going to do an example. So for the first interval, x is greater than -4, we're going to test x is equal -5, which is a number in that interval. So we're just going to substitute in -5 as x, and what we get is -5 plus 3 over -5 minus 2 times -5 plus 4. And what that gives us is -2 over 7. So what we can see is that this number is less than 0. It's not greater than 0. So that means that, therefore, x is less than -4 is not part of the solution. I'm going to keep testing values of x for each of the intervals, but instead of how we did it in the example, I'm only going to find the sign of the factors instead of exact values, and then use that to find the sign of x plus 3 over x minus 2 times x plus 4, since that'll make it quicker, and I've shown how to do it in the example. So the first example that we have is -∞, -4 with round brackets, and then we have -4, -3, and then we're just going to include the 0 of the numerator to show what it looks like compared to the other intervals, but it's not actually an interval. And then we have -3, 2, which is an interval, and then 2, +∞. So the test value of x, we're going to choose one in each of the intervals. So for this one, I'll choose -5 as I did in the example. And then for -4, -3, I'll choose x equals -3.5. For -3, it'll just be x equals -3. For this one, I'm going to choose x equals 1. And for this one, I'll choose x equals 4. Now we're going to find the sign of the factors. So the sign of x plus 3 when you let x equals the test value, the sign of x minus 2 when you do that, and the sign of x plus 4 when you do that. So if I let x equals -5, what's going to be the sign of x plus 3, that factor, the one in the numerator? Well, it's going to be a negative. Then for x minus 2, it's also going to be a negative, and for x plus 4, it's also going to be a negative. Then if we let x equals -3.5, the sign of the factor in the numerator will be a negative, because -3.5 plus 3 is negative. And then if we do that for x minus 2, it's a negative, and x plus 4, 3.5 plus 4, is a positive. So when we're doing this, not an interval, just the 0 of the numerator, of course the numerator is going to be 0. And then for x minus 2, that's going to be a negative, and x plus 4 will be a positive. Then for x equals 1, we're going to get in the numerator, it's going to be a positive because 1 plus 3. And then for the factors in the denominator, x minus 2, so that's going to be a negative, and x plus 4 is going to be a positive. The test value of 4, so the sign of the factors is going to be positive over a positive times a positive. And now we're going to find the sign of x plus 3 over x minus 2 times x plus 4. And for this one, since it's a negative divided by a negative times a negative, it's negative. Negative divided by a negative times a positive is a positive. Then 0 divided by anything will be 0, so that's going to be 0. Then a positive divided by a negative times a positive is a negative. And a positive divided by a positive times a positive is positive. Summarize the information I got in the table above in this table, which is just the test values and the critical values, the rational expression in red. So we know that at the test value of -5, the sign of x plus 3 over x minus 2 times x plus 4 is negative. At -4, it is undefined. And then at -3.5, it's positive. At -3, it's 0. At 1, it's negative. At 2, it's undefined. And at 4, it's positive. The test values in table gave me the sign of x plus 3 over x minus 2 times x plus 4 in every interval. I know that whichever intervals this rational expression is positive in are its solutions, because positive numbers are greater than 0, so values in these intervals make the inequality statement true, whereas wherever they're negative would not be true for this inequality statement and would not be a solution. So looking at the table, I can see that x plus 3 over x minus 2 times x plus 4 is positive in the intervals -4, -3, and 2 comma positive infinity. So that means that, in other words, for this inequality, the solution is x is greater than 2 or x is greater than -4 and less than -3. Now I'm going to show the solution from up here on a number line. So first we'll do x is greater than -4 but less than -3. And we're going to use open circles since it's greater than, less than, not greater than, and less than, equal to. So the open circles on both those values and a line in between them. And I'll just write the interval down. And then we have x is greater than 2. So that's going to be an open circle from 2 all the way to positive infinity. And I'll put that in red to make it more visible. I'll write the answer in interval notation. So therefore, the solution set for x plus 3 over x minus 2, x plus 4 greater than 0 is so that would be the answer in interval notation. I'll just box this. This is the solution set. And then I'll box the number line, which is the other format I put the answer in. And then I'll box this. For this inequality, the solution therefore is x is greater than 2 or x is greater than -4 and less than -3.